I've worked in food service, and I've gotten people who don't know how to make a recipe 3 times larger than it should be. And I can say to them, you need to double that recipe or you need to triple that recipe. And what they'll do is they'll take the half cup and they'll measure 3 times with it, rather than realizing that, oh, that's a cup and a half. And probably they could do the fraction work in their math book, but it never jumped to understanding how to use it in everyday life.
The Math You See curriculum that I use here, what they really want the students to understand is the why of math. So, for example, if I have a multiple digit multiplication problem like 14 times 12, when I went to school, my teacher just told me where to put the answer. So this is 8, this is 2, 4, and 1, and we add it, and that's my answer. But not understanding why the numbers go where they do.
For some students, their math sense is kind of innate, and learning those processes will give them what they need, because they'll make the connection between the concept and the process. But most of us have students sitting in our classroom who will never make those connections or make them accurately on their own. If they don't make the connections between the concept and the process, their ability to use that math outside of a textbook is not what we hope it will be for them. With Math You See, we teach students that multiplication is a block or a rectangle. And when they begin learning multiplication facts, we often build those rectangles with them. So if they were doing 5 times 3, they would take their 5 blocks, and in Math You See, each of the blocks is a different color, which makes it really easy for them to distinguish where they are. 5 blocks are light blue. And they would build a rectangle that was 5 across and 3 up. So when we talk about dimensions, we actually don't use length and width. We teach them to say across and up. And it's not a big difference, but it's a more natural way to talk about it for younger students. We often have them build the rectangle. Sometimes I have them do it on a marker board, and then they would write the dimension 5 underneath and 3 across. And that's a visual for them to understand the multiplication. Sometimes we say 5 times 3. Sometimes we also talk about it as 5 counted 3 times. So one way that I teach this at the beginning of third grade is to have them count. They build the block and then they count it 5, 10, 15, and they move the block as they go. Once they've learned to build those basic blocks and they've learned their facts, the first number of lessons are about the facts and about multiplication. You also teach area with multiplication.
If you want to find the area of a rectangle or a square, you have to know your over and up dimension here. And so that's what this really is. This is actually showing me I have 14 over and I have 12 up.
The next step, once they've learned all their facts, which really takes the first half of the year or so, is that they move into multiple digit multiplication. And so to do multiple digit multiplication, they first need to learn to build larger problems.
We build it with our manipulatives. So I look at my top number here and I know I have 14. So that means I need to have one 10 bar and a 4 bar.
So if a student is doing this problem, to begin with, we're going to build the problem. And our over dimension is 13 and our up dimension is 12. Sometimes we mark that, the over dimension and the up dimension, and then we build it.
And my goal here is to make a square, because multiplication is actually a square.
And we start with the over dimension, which is 13. So to make 13, I take a 10 block and a 3 block. And that's 13, 10 plus 3. And then we need to make it 12 up. We take a hundreds block, which is, of course, 10 high and 10 across, 10 over and 10 up. And we put that on. Now I've got 11 and I need 12. So I add another 10 block just to get my 12. Right now we're only focusing on the up dimension. So we got that, it's 12. And then we need to fill in. 13 is right here, going across 13. So we'll fill that in. Put another 10 block there and a 10 block there. and 10 block there, and that fills me up right to that. And then obviously I need another 3 there.
This is my answer to a multiplication problem. And so they think, great, I can just write it in. But I have them actually break it down, tell them to take this square apart.
This takes a while sometimes for students to learn. I found that I needed to take a lesson a day or two and have them work with building blocks. For some of my students that came pretty easily, and for some of them it didn't come quite as easily to move into these larger blocks. One of the really neat things about this is that when you look at this block, you actually see the 4 problems that you do as you multiply.
So they have to put it into their place value. So they'll bring their units over here, their tens are right here, and this is the hundreds place.
So when you work with a problem like this, there are 2 ways that you can work with it, and it's good for students to learn both ways. The first way, or one of the ways, is to use what Matthew C. calls place value notation. It can also be called expanded form or expanded notation in different curricula. Place value notation is when you take a number, like 13, and you divide it into its units and its tens. And if you had more numbers, if there was hundreds or thousands, you would divide it out that way.
I have my student break this down into its place value. So they know that 14 is 10 plus 4. And they know that 12 is 10 plus 2.
So to write 13, there are 3 ones in 13. So we write a 3, and there's 1 10. So we write a 10. You put a plus sign in between because 10 plus 3 is 13.
The important thing is that they understand place value. So this 1 actually is 10. It's not 1. And this is actually 4 units.
And students can see this with the blocks. If they make 13, you're going to put your 1s here. Here's your 13, your 10s here. And you can split it apart into your units and your 10s.
That is what they want them to understand here, is the why. Why is this 10 plus 4? Well, it means it's 110 plus 4 of these.
So our place value notation for 13 is 10 plus 3, and for 12 it would be 10 plus 2. There's a 1 in the tens place and a 2 in the units place.
If they still get a little confused, I have them draw a line like this. And so this is my units, this is my tens place, and this is my hundreds place. So that's his home, is what we would call it.
If we multiply this, you can see the 4 different problems that the block shows us. So the first problem is 3 times 2, or 2 times 3. The second problem is 2 times 10. And then the third problem is 10 times 3. And the fourth problem is 10 times 10. And if you look at the block, you see those 4 problems. The first one, 3 times 2. The second one, 2 times 10. The third one, 10 times 3. And the fourth one, 10 times 10. So when we multiply, we go 2 times 3, and that's 6. That was our first step. Our second step is 2 times 10, and that's 20. We write that in the tens column, and go ahead and put our plus sign in between because we're going to add those 2 numbers together, ultimately, in the end. And then we move over here. 10 times 3 is 30. It's really important to keep that lined up in the tens place. It does not go in the ones place because 30 doesn't go in the ones place. It's too big for the ones place. We would have to move it over because it would be too many numbers here. You can only have up to 9 in the ones place. And then we have 10 times 10, that's 100, and that has to go over here in the hundreds place. When we're all finished, we go ahead and add, and we get 6 plus nothing is 6, 20 plus 30 is 50, and 100 plus nothing is 100. When we're finished, you can add everything together, 100 plus 50 plus 6, for your final product, which is 156. So when I built this problem, I was thinking about it from my perspective, but and I'm used to doing my blocks on a board. I have a magnetic set of blocks. But if you're doing it for students and you're on a flat surface and they're looking at it, you need to make sure that you keep your place value line up. So probably the block should have been built like that because these are your ones. You're going to want them on the side that students would see the ones on, which is their right to your left.
I have him teach it back to me, and once he can teach it back to me, I know that he has mastered it. And then we move on to this.
One of the really fun things that Matthew C. does, I've never seen any other curriculum do, is the way that they teach multiplication, not in expanded form. I like this because it mirrors the expanded form experience. So if you go 2 times 3 here, we get 6. And 2 times 1 is 2. And then this is 10, just like you see it here. 10 is the 1 is in the tens place, so that's a 10. 10 times 3 is 30. And because it's a 30, we have to put the 3 in the tens place. If you want to, you can go ahead and fill in that 0 here, or sometimes I have my students make an X to show that there's nothing in that place. But the 3 from 30 has to go in the tens place to keep it lined up with the 2 from 26. And then we move on and go 10 times 10. Again, the 10 is in the tens place here and here, so it's 10 times 10, and that's 100. 100 goes in the hundreds place, the 1 from 100. And now we're able to add everything together. 6 plus nothing is 6, 2 plus 3 is 5, and 1 plus nothing is 1, for a final product of 156. There's a very strong idea that the writer has, the person who designed the curriculum has, that students are going to learn something, they're going to master it, and then they will be able to move on to the next step. Part of the idea there is that they spend longer on individual pieces of the process. So in the first book, which is Primer, they're learning just numbers, number sense, very simple addition. In Alpha and then Beta, they work with addition and subtraction. And by the time they get to Gamma, which is the 4th level, a lot of people would think of that as a 3rd grade level, they are supposed to have mastered addition and subtraction, and they'll continue to review that. But the idea is that that foundation has been laid, and they're ready for multiplication. So in Gamma, they learn how to multiply the whole way up through, at the end of the book, multiplying multiple digit numbers together. It's fairly high-level multiplication for a 4th grader. And then when they move on to Delta, the 4th grade book, they learn division. So it's very structured. And part of that structure is that each thing builds on the next. So if you learn multiplication fully, you should be able to move into division with confidence. Along with that, there's a lot of emphasis on students understanding what they're doing and not just learning a process. So that's why you're going to spend as much time as you do with place value notation, or place value and place value notation, because understanding place value is really important to understanding how multiplication works. Otherwise, you can learn a process, do this process, and your answer will be right. But you're not really understanding why it's right, or why you have to put this number in the tens place and not in the hundreds place or the thousands place or the ones place. That's a really important piece of Matthew C. that maybe is not as strong in some other lower elementary curriculums. The sense of students learning why they're doing what they're doing and understanding it. You also see it in story problems. Their story problems are a lot less formulaic. The students actually have to picture what they're doing, picture what the story problem means. So there's a good deal of comprehension, not just, oh, I see this keyword, that means I multiply, or this keyword means I add, which hopefully translates into better math sense as they move on into, of course, upper grades, but also into their lives outside of school. I think you should be really aware of a couple of things. Matthew C. was initially designed, as I understand it, to be used more one-on-one and individually. And so there are distinct challenges to taking a group of students and moving them through Matthew C. I think there's a common misconception that Matthew C. was a remedial program, and it's not. It is on grade level. Because of the focus on individual processes, multiplication, addition, subtraction, in different grades, it doesn't align completely with a traditional math curricula. And so if you are switching from a traditional math curriculum to Matthew C., you need to be really aware of where your holes are going to be and have a plan for what you're going to do to fill those gaps. There is that switch that happens when you move from any curriculum. When you move from a curriculum that is very traditional to one that's less traditional, the gap is going to be larger, and you're going to have to be really careful with what holes are getting left. The other thing I would say with Matthew C. is that their review is not as strong as many students need. So you're going to need to supplement with lots of review, both fact practice, but also concept review, vocabulary review. They do not incorporate that into their curriculum as much as, in my experience, you need to incorporate it in a classroom. Even just being able to walk through the store and say, oh, that's 20% off, and quickly and roughly figure out what you're paying for an item. Those are the types of connections